Hello guys, welcome back to day 14. I believe we're day 14. Today we're going to be doing the before last problem of LeetCode. We have longest consecutive sequence. And they're giving us a time complexity, an exact time complexity. This can be a little tricky. I've never had a problem where they tell us, make it a log of n times. So we're saying, given an array of integers, return the length of the longest consecutive sequence of elements. So, I see. Return the length. Why is it 4? Is it because 4 is the one that pops up the most? Let me see over here. That's interesting. Oh, I see. 3, 4, 5. 2, 3, 4, 5. So it turns it. Over here it's gonna be 0, no, 2. Wait, what? 2, 3, 4, 5. 0, 2. What? It seems like 0, 1, 2, 3. Wait. 0, 1, 2, 3, 4, 5, 6. I see what they mean. If you sort it and you pop the duplicates, how many? Okay, this could be tricky. Alright. Consecutive sequence is a sequence of elements which each element is exactly one greater than the previous statement. So 2 for loops is not going to happen. Okay, so let's visualize a problem. Number 1, how can I solve this problem logically? So, number 1, we could sort them. So let me just experiment real quick. I was thinking about backing down and Loki doing Sudoku problem, but I'm not about to do that. So we have these number values. Right? If we do print the sorted version of this, 2, 3, 4, 5. Plus 1, plus 1, plus 1. Okay, so what I'm thinking, right, as we sort the list first, and then we think, okay, the first value is 2. Is there a value that's 3? If there is, we're gonna, you know what I'm saying, concatenate them into a single list. Then we're gonna check if 3, is there a number greater, is there 4 in the list? We're gonna see if there's 4 in the list. If there is, we're gonna say it's 4. Oh, we're gonna see if there's 5 in the list. Okay, there is. We can concatenate to the list. Now, is there 6 in the list? No. Then we're gonna stop it here, and we're just gonna return the length of the list. But the thing is, this could be 4, but then you see like later on there's like 8 in a row. That's what's tricky. You want to return the longest consecutive sequence. That's tricky. Okay. A set is ordered. I think we should use a hash set. Yeah, I think we should use a hash set. Okay, so I'm having a little issue, and I'm gonna try to like maybe speak it out, and maybe my thoughts will be cleared out. So the biggest problem I have, right, is it's able to find the next one in the list, and if it does, it appends it to a set, which eliminates duplicates. But the biggest issue is that 2, 3, 4, 5, right? Wow. Over here, 10. Oopsies, there's an issue. There is no 6, so we should just break that, right? What I'm thinking is we take the value for numbers and we pop that list. And then we check for the rest of the values here. But I don't know how to dynamically create. It's not even, I don't even think that's efficient either. There's gotta be a simpler way. But like, it's not gonna pass the test cases 100%. I need it so like, whether it's in the first portion or the last portion, it takes a set of values and it'll see which portion is the longest consecutive series of numbers. So 10, 11, 12, 13, 14, 15, 16. This is clearly longer than 2, 3, 4, 5. But the way I set up my for loop is that it'll only stop at 5 and it'll cut down because I sorted it. And even if I find like the list over here, let's say for example it ends at 14, that's 3 compared to 4, which takes 4. So the thing that came to mind is like I should have 2 hash sets. And as I increase the consecutive loop, we add into the first hash set, right? Until we don't. If we don't, I'm thinking we should pop those numbers into a list. So I do like, let's say for example, X over here, and I do X. I should also do, since we don't know what the range exactly is, because we are going to be popping it. Bro, this is tricky, bro. I just came after the gym. This is so tricky. Else we pop the values. Maybe my approach is not good. I think the sorted thing was okay, but the way I'm approaching the length of numbers and stuff, I don't think that's the right way to go about it. Maybe I should be looping for every value inside. Maybe. Would that help? I'll just do the value, so I plus 1. But it doesn't change the fact that, like, I find the values, okay, it works out, but if it doesn't work out, I need to make sure I delete the lists of values that I found. And then that's not even optimal, bro. I'm thinking about just checking solution. I ain't gonna lie. Like, there's just one thing I just don't know how to do, or maybe I do know how to do, but I just can't figure it out.
Let's solve LeetCode 128 longest consecutive sequence. This is a pretty interesting problem, and it's actually been asked by a lot of companies, including Google, for a coding interview, so I think it's a good problem to understand. So we're given an input array of numbers, right? In this case, we have 6 numbers, and we want to find the longest consecutive sequence. In this case, the longest consecutive sequence is 1, 2, 3, 4, right? It doesn't matter what order the numbers appear in the input array, we just want to know the longest consecutive sequence that we can make from the input array. Now, the most obvious way to solve this problem is just by sorting, right? So if you look at the sorted array over here, we have obviously one consecutive sequence of length 4, right? 1, 2, 3, 4. They're all consecutive numbers. We also have another one that's length 1, just 100. And we have the last one that's also length 1, just 200, right? Now, this is definitely a valid solution. We can definitely...
the way he thought about it kind of clicked. I will not lie. If I sort everything... Whoa. Okay. I thought came in mind, which is literally what I thought earlier, but I didn't do it. You know what I'm saying? So let's just say, right? We sorted it, right? Then we delete those values. So we're gonna do, let's say, like, we do sorted of nums. Then we're gonna go over here. We just do dot copy. We do right, and keep it nums, right? Then we find the value. If you find the value, we're gonna add it to set, right? And then we pop those values from the x. Let's try x. And we go over here. We do x dot pop I, and do x dot pop index. So x dot index. So we're looking for the position. So we remove those two numbers and we add it to the hash, right? Now, if we don't find it, then we're just gonna continue. Whoa, whoa, whoa. I think I'm cooking, but it's like weird. How to find the largest? I'll try this, and then if I can't do it, I'll just check the solution. No, I just want to find, like, which one is larger. You feel me? Like, then I take the lists. I want to make them into a length value, so it's a number, and then just try to find the max value of that. Maybe that's too much. Oh, actually, it might work. Maybe. So if it doesn't work, okay, if we don't find that next find, then we're gonna set L is equal to R. Now we're gonna do R is equal to L, right? Because they're both sets. L dot copy, right? We're gonna make a copy of it. And then once we make that copy into that new set, we are going to check. We're gonna check if the length of L is greater than or equal to the length of R, then we're just going to replace it. If the length of the list we're going with, it's a huge list, right, is greater than or equal to that length, then yeah. If not, low-key else. If not, then we're seeing that, like, for example, R is greater, then we're just gonna do L dot clear for that version, and then over here we're gonna do L dot clear for this version. Okay. Now explain to me, if you're able to find the value, how are you not able to pop it? I'm actually done with this. What is this? We're popping the ith value, the index's value. Maybe if I swap it, bro. Maybe. I doubt it, to be honest. How is it just not in the list? Maybe like that. It might be a good time. It might be a good time.
Code this up, but the time complexity is going to be O n log n. So the question is, can we do better? So this is a LeetCode hard. Obviously, the solution wouldn't be this simple, so we can do better. But how do we get there? Now, the first thing to do is try to visualize the problem in a way that it makes the problem really easy to understand. So I visualize the problem by drawing out an imaginary number line, right? So we can kind of see what the sequences actually look like. This makes it a lot easier to recognize the patterns. So we know we have one sequence that starts at 1, 2, 3, and 4. We have another sequence that comes after it with just one number, 100. We have the last sequence with also only one number, 200. So just by looking at it, we can tell we have 3 distinct sequences, right? That's something to recognize. Now, by visualizing it, we can kind of try to approach how would a human solve it. Well, the easiest way is just look at each of the sequences, right, and count how long they are. So let's look at the first sequence, right? We have 1, 2, 3, and 4. So this sequence has 4 numbers in it. We have the second sequence, just 100, so it only has 1 number in it. So it's a sequence of length 1. The last one is also a sequence of length 1. Now, this is so easy to solve when you visualize it and try to approach it how a human would. But can we actually convert this into code somehow? The answer is yes. So the most important thing to notice is that we have 3 sequences, but how can we identify what makes a sequence? How can we actually start at the beginning of a sequence? The thing to notice, and this is really easy when you actually look at the picture, that each sequence has a start value. The start value, in this case, the start value for the first range, or the first sequence, has no left neighbor. The first value 1 has no left neighbor, right? That's really obvious. Look at the second range, 100. It doesn't have a left neighbor. The third range, 200, doesn't have a left neighbor. So we can get the start of each sequence by just looking at our entire array of numbers, right? And figuring out which numbers don't have a left neighbor. So meaning if we wanted to check if 1 had a left neighbor, we would check, does our array contain the number 0? If we wanted to know if 100 had a left neighbor, we check, does the array contain 99? The easiest way to do this and the most efficient way to do it is by taking our initial array and converting it into a set. So now to find the start ranges, let's start iterating through our array. So we get to the first element, 100. Does it have a left neighbor? Well, we can check our set. It doesn't have 99 in it. So this is the first, so this is the start of a sequence. So let's get the length of the sequence. We start at 100. Now to get the length of the sequence, we want to count how many consecutive numbers come after 100. So we want to know, does 101 exist in our sequence? Looking at the number line, obviously it doesn't, but how can we check this efficiently with code? Well, we already have a set that takes up this entire array, so let's just use our set to check if 101 exists. Since it doesn't, we can no longer continue this sequence. So now we get to the next number, 4. Is 4 the start of a sequence? Let's look at our picture we drew. 4 is not the start of a sequence, and we can check this using our set. We would check that it does have a left neighbor, right? 3, so it's not the start of a sequence. We're not going to make a range from it. We get to the next number, 200. Is this the start of a sequence? Looking at our picture, yes it is, and we know that 199 does not exist in our set. So let's make the sequence. Let's try to make it as long as we can. We check, does 201 exist? No, it doesn't. We can tell that from our picture, and we would use the set to determine that. So now this is as long as we can make this set. So let's get to the next number, 1. Is 1 the start of a sequence? At our picture, we can tell 1 does not have a left neighbor, so it is the start of a sequence. Now let's check if 2 exists in our set. It does, so we can make this sequence a little bit longer. Now let's check if the next number, 3, exists in our set. Yes, it does. So let's make it even longer. Now does 4 exist in our set? Yes, it does. Now let's check if 5 exists in our set. It doesn't, right? There is no 5, so we can't make the sequence any longer. So now let's continue through the array. 3. Is 3 the start of a sequence? No, it's not. It has a left neighbor 2. Now let's try 2. Is 2 the start of a sequence? It's not, because it has a left neighbor 1. So we went through the entire array. We created all the sequences we could. The first sequence is length 1. The second sequence is also length 1. The third sequence is length 4. So this is the longest sequence. Now we took a really complicated problem, or seemingly complicated, and we broke it down so easily. All we had to do was iterate through the initial array, use a set, and check if values had left neighbors, and if they didn't, then they were the start of sequences. We made this problem so easy with only using one data structure. Since we only had to iterate through the entire array, and we had to expand each range, we know that we're only going to visit each number at most twice, so our solution is very efficient. And we did have to use additional memory to create a set because we wanted to check if neighbors existed. So for the memory complexity, it is also big O of n. In this case, n is the size of the input array. So now let's get to the code. So we remember we need to create a set from the initial array nums. So it's really easy to do that in Python. We can just pass the array into a set constructor. Next, we want to keep track of what the longest consecutive sequence is. Initially, we can say it's 0. So we want to iterate through every number in the nums array. And we want to check if it's the start of a sequence. And we can check that simply by checking if n minus 1 does not exist in our num set. If this number doesn't have a left neighbor, that means it's the start of a sequence. So now we want to get the length of the sequence. Initially, we can say the length is 0. And we want to keep getting each consecutive number and checking if it exists in our num set. If it does, then we can keep expanding the length. So initially, I'm going to check n plus length because that's going to check the current number. Initially, length is 0, so we're just checking the current number. As the length grows, we'll check more consecutive numbers. At the end, we could have potentially found the longest sequence. So we want to potentially update our longest by just taking the max of the current length we just computed, as well as what the longest originally was. And it's really that simple. So now all we have left to do is just return what the longest sequence was that we just computed. So we did this in such a small amount of code. Now let's just run it to see that it works.
Genius. It hurts my brain. Like, I got the first idea of getting a set, but the thing is, the way you visualized it in the code makes more sense. So if the nth value, so let's see, the first value is like 1 minus 1, so 0. If 0 is not in the list, then we start with 0. And we go all the way through. And then we're just going to see if the n, so while n plus length, what? Yeah. We're going to do length plus 1. And then it's going to be n plus 1. So if we're going to see if 2 is in here, 3, 4, 5, 6. Let's say if it's false, longest equal, so in between length and the longest.
The longest originally was.
Genius. I'm so plagiarizing him, bro. Bro, that's so smart. So num says gonna be equal to a set of the numbers. I love K. He doesn't even sort it, bro. He doesn't even sort it. 1 equals 0.
It's really that simple. So now all we have left to do is just return what the longest the longest sequence was that we just computed. So we did this in such a small amount of code. Now let's
Man. Got a long way to go. I can't lie. This type of condition is not even that hard, but bro, it's just so well thought out. Low-key, next episode, we're gonna have to hit up my iPad, plus visually understanding a problem. Tomorrow we're doing Sudoku. Hopefully I'll be able to solve that. And yeah, once we're done with that, we're done with the first act. Yeah, we'll be done with arrays and hashing. I'll be hitting up 2 pointers and stacks. I think we can do pointers and then stacks. But yeah, see you guys tomorrow.